Hi everyone, my name's Simon. I'm from Space Architects based in Oxford, and today today I'm talking about the challenges of retrofit, and just a little bit about us. We are an architects practice based in Oxford. We specialise in low energy buildings. We do both architecture and research.
Can you speak up a bit, please?
Yep, I'll try. So we specialise in ecological design, energy efficiency, passive house, growing food on buildings, and of course low energy retrofit, which is what I'm going to talk about today. So what is it? Well, we like to take a fabric first approach. So roughly in this order, basically. So looking at insulating and making airtight the building fabric, upgrading windows if they need replacing, looking at upgrading the space and water heating system so that you can improve efficiency and potentially use low carbon technologies, reducing energy requirements for lighting and appliances, so really getting down energy requirement for the building before then actually attaching renewable micro generation, so things like solar PV panels, that kind of thing go right at the end, once you've actually brought your energy down and then you've got not much energy left to produce. So why is it important? Well, I'm sure most of you probably know that already, but just to give a bit of context, UK government have declared a climate emergency to cut net zero by 2050 effectively, which actually isn't that it's not very far away. The household sector represents 20% of total greenhouse gas emissions, which is a huge amount. And I think this last statistic is always a bit of an eye-opener, that actually 80% of the houses that will be standing in 2050 have already been built. So yes, new build is important and we need to be getting new build net zero, but actually the big picture is we're going to have to be upgrading all of our housing stock in a very short space of time. In terms of challenges, given we've got limited time today, then I'm going to focus on the technical aspects of retrofit, but we can talk about financial, political challenges as well. But today I'm going to talk mainly about the technical issues, looking at the various retrofit measures. So in terms of wall insulation, your options really to insulate externally or internally. The benefits of external insulation is you get complete coverage. So that's the ideal, that you basically wrap your house up like a tea cozy, so that you minimize any thermal bridges. You can generally get thicker insulation on the outside, means you don't lose any floor area on the inside. Of course, the downsides mean it affects the external appearance. So if you're in a conservation area or if you're a listed building, then there may be planning challenges. And then you have to think about the detail at the base and the eaves, and you may need, it's more of a specialist installation, so you probably need scaffolding. You need to take off rainwater goods, solvent pipes, that kind of thing. So it's quite disruptive, quite a lot of work. Insulating internally, well, I guess it's almost like the opposite. So in terms of benefits, you don't affect the external appearance. So listed buildings, conservation areas, ideal for that. You can do it all from the inside. Generally, it's a simpler install. I mean, you still need to take off electric faceplates, radiators, skirting boards, that kind of thing. So it's still very disruptive. And ideally, you want to insulate down the wall and through the floor. So you need to lift up floorboards and push in insulation behind that as well. So it can be quite disruptive. And of course, the downsides, you lose floor area. there are potential condensation risks if it's not done properly. So you need to make sure it's the right amount and the right type of insulation. So maintaining vapor permeability if that's important. Otherwise, yeah, you can create all kinds of problems, which I'm sure you've heard about in the media, about sort of horror stories about, you know, mold growth. That's also a lack of ventilation as well. So they really, you know, you want to think about insulation, air tightness and ventilation. They all go hand in hand, really. And any junctions with the existing structure, you just think about how those interfaces work. With the roof, well, again, you go above, between, or below the roof rafters. I mean, sometimes it's a bit of a hybrid of both, but things to think about, well, you know, if you're on a terraced house or a semi-detached house, then, you know, insulating above will mean you change the level of the existing roof line. So how do you deal with that? And are there any planning issues in doing that? Making sure, again, you're ventilating, you know, most roof structure is timber structure, so you need to ensure that they're well ventilated so you don't have any condensation problems there. Thermal bridge through the rafters, so energy moving, heat moving from the inside to the outside through the rafters. If you insulate, if you can put a complete continuous layer either inside or outside, then that reduces that. And of course, if you're in a loft or, you know, insulating internally can reduce head height there as well. So lots of things to think about. In terms of the floor, well, again, lots of different floor types. You know, you've got your suspended timber floors from probably 1930s and before that. That's a bit easier to install insulation because you can, you know, lift up floorboards, insulate between the joists. You just need to maintain enough ventilation below. You need a minimum of 150 mil ventilation void below, just to avoid any condensation, and also kind of free flowing air bricks, so you get free movement of air. And of course, if you don't have that, then you need to start digging up the floor, which can be a much bigger job. A lot of houses, sort of 1940s, 50s onwards, have solid concrete floors, so that is more of a challenge. You know, you can either, if you want to do it, insulate properly. Some people do dig up those floors, which again is a lot of disruption and a lot of costs. Or you can go for a thin layer of insulation that goes on top, but then that will affect floor levels. So you have to think about stairs, doorways. Basically, you can't go too high, basically, otherwise you just have to change all your door heights and everything. Point load of insulation as well, so making sure that it's the right type of insulation, or you have the right finishes so that you're not penetrating it. Thermal mass, so that's just, you know, having a screed or solid concrete floors has its benefits in maintaining temperature, making sure it is not too high fluctuations in temperature. And of course, yeah, services, I mean, that goes with walls as well. I suppose roofs to a certain extent is that, you know, where you put pipework, electrics, that kind of thing. Then there's a question of, you know, do you go natural or synthetic? Generally, natural materials have a much lower embodied energy, sort of better environmentally, generally, but they tend to perform worse than synthetic materials. Synthetic materials, kind of plastic-based materials, generally you can have a lot less of it, you know, much thinner insulation that will achieve a better U value, better thermal performance overall. But also generally, you know, speaking generally, you know, obviously different products have their own characteristics, but are generally less breathable in terms of vapor permeability, so that can create issues. Embodied energy much lower with natural materials, and ecological impact as well. There's also off-gassing, which is something to think about. You know, a lot of people probably don't think about that, that you can get. So release of VOCs, so volatile organic compounds, nasty things basically that can go into the air that when you breathe them in can create lung problems or other kinds of issues, which tends to be present in the synthetic materials. So if you're particularly vulnerable to that, then natural materials is probably the way to go. So challenges in air tightness. So ideally, like I was saying before, that goes hand in hand with insulation. So you want to maintain a continuous layer of air tightness throughout the house. That goes on the inside layer of the insulation. That's to stop air movement and heat loss through infiltration and exfiltration. So that's sealing any kind of gaps basically around windows. You'll have some surface penetration, so SVPs or extract fans will obviously go through walls from inside to outside, but there are products, grommets or tapes that you can tape around those just to seal those off. Air tightness, depending on the level of air tightness, you need to think about ventilation and making sure you've got enough air movement so you don't have those moisture problems that can create issues. So again, ventilation, those are the three things we need to really think about. Often when you get the problems, it's because people just focus on one thing, one or two of the things, and don't think about it as a whole. But you do need, if you're talking about passive house levels of air tightness, then you really need mechanical ventilation and heat recovery to maintain a good quality of indoor air. But again, with a lot of I'm talking about retrofit here. So, okay, yes, you can go to Enofit, which is passive house levels of retrofit. It's incredibly expensive and disruptive, so it's probably not the way forward in terms of mass retrofit. I think we need to think about a kind of hybrid or slightly reduced approach where we're trying to get as many houses as we can up to a certain level, but not necessarily to passive house, because I think it's just not economically viable to do it that way. And so going for slightly not as strict measures, you can get away with trickle vents in windows and extract fans in wet rooms, which is a kind of the standard way of doing it in this country. So in that sense, it's much less disruptive. And things like, you do need to think about fan noise. Things perhaps that we're not used to doing in this country. We like to open windows here. And mechanical ventilation can create noise, background noise in rooms. And then, obviously, ventilation units need electricity and maintenance as well. So I'm just going to finish with some photos of some real projects, just to kind of show you. It's nice to look at photos as well, just to see what things look like. But in terms of, so this is to show this house is going to be externally insulated. It's actually my colleague Paola's house. Some of you may have been there. She opened it up to sort of open house so people can look inside it. But yeah, so insulating externally, it is disruptive. So you need to have scaffolding, which is quite disruptive. It's also an additional cost. You may not have the space to do that. So obviously, we've had to borrow some space from the neighbour to be able to do that. Again, to do it properly, you should dig a trench down the side of the wall so that you insulate down below and down to the foundation, just so you reduce that thermal bridge through the foundations and wall. So again, that's more work to have to dig that trench. And below DPC, so damp-proof course, you do need to use a different kind of insulation. So in this case, it was an XPS, which is extruded polystyrene, which can get wet basically and won't degrade. It's a bit more pricey, that insulation, but that's what you need to put below the ground. And also, we've got this sort of black painted on liquid damp-proof membrane just to ensure that we don't get any damp issues below ground. And that's just a shot of that XPS insulation. In this particular case, it was a Kingspan. What's it called? Green Guard, I think. Green Guard. So yeah, you go for a slightly thinner insulation below the ground. You know, some companies will come in and insulate your house, but they won't dig that trench, so you'll just insulate the walls. But if you imagine there's a lot of walls still below the ground, so you're getting a lot of heat loss through that the base of the wall. And then above, so there's not a picture of this, but above DPC, we put two layers of 80mm wood fiber insulation on the outside, and this one has a sort of pebble dash. So you need to kind of put a base layer of basically to make it, to smooth it off, basically, so that you have a smooth finish to lay the insulation onto. This was a Victorian terrace where we put internal wall insulation on it. And you can see how, once you start taking finishes off, you see how wobbly the walls are, and how many gaps, and kind of there's no mortar in places. So it's a building that's over 100 years old, so it's not going to have lots of straight lines. And this next photo shows you how that's the build-up of. So this is your sort of wobbly wall, and actually you need to put a sort of base layer, a parge coat of lime, just to smooth it off, basically. And then internally we put, I think it was 60 or 80mm of wood fiber insulation, which it's a natural material, so again low embodied energy, but it crucially is vapor permeable, so it allows moisture to move through the wall and not condense in a place that can create problems. And then on the outside would just be a lime plaster finish, again breathable, and then after that as well a vapor permeable paint as well, because you can you use a non-vapor permeable paint which could create issues as well. So you don't want to do it right at the last bit. And that's just to show. So, I don't know if any of you have been our stands. We've got a couple of samples of the products, but you would have the rigid wall insulation above, and ideally you want to insulate between the joists as well. So lifting up the floorboards and using in this case, a flexible wood fiber insulation, because it can be sort of squashed in, and, so you don't have any gaps around the insulation. And yeah, that's come to the end of my presentation. So just a list of references, and got 10 minutes left, I think, for any questions.
On the Victorian house, the photo showed that you've taken off the plaster and gone back to the brick. Is that the best way to do it, or can you insulate secondary over the existing plaster wall on the external wall?
So you can. So in that particular case, it was because they had used a cement-based plaster internally, right. So it was no longer breathable. Right. So the best practice was
if you've got traditional plaster.
Yeah, because traditional lime plaster, yeah, you could just insulate straight on top of that. At the back.
What are the fire risks associated with either wood fibre or synthetic insulation?
Fire risks. So actually wood fibre is, you would think, oh, it's wood, it must burn very quickly, but it's so dense. They've actually, you can go online on YouTube, these videos where they actually test, they put a blowtorch on wood fibre and actually it barely burns, it doesn't even combust, it just kind of somehow survives. So there's no issue there with putting wood fibre in. It's all about air, isn't it? Like presence of air that makes fire combust. So in terms of synthetic, I mean, I don't know if you're referring to, Grenfell, they obviously use PIR in that case, but I don't think it was the insulation itself, it was more the air void that allowed.
Especially oil-based ones, which give off the VOCs.
Yes.
It's oil-based, you should put gallons of oil all around your house.
Yeah, I mean, in the event of a fire, yes, it would be a bit of a disaster, but it would, you would ruin your house, basically.
But does the window not render on the outside?
The window,
No, render.
do you render the outside?
Yeah.
If you're insulating externally, you need to render it or have some kind of finish on the outside.
So does that improve the fire? Increase the hazard?
I guess the insulation on the outside, it's less of an issue, though it's not in the home. But on the inside, yes, it would be more of a problem on the inside.
Then built some chimneys. Is it safe to block them up in winter so as you open them up in summer? Sort of 6 month or 4 month rotation safe in terms of condensation?
Yeah, I've not really thought about it in that sort of, that's doing, changing it through the seasons. I think essentially you want to, I mean, you should maintain the air brick for flow of ventilation, but maybe if it's capped off at the top, then there's no issue in water coming in. It's certainly, but I mean, in principle, that sounds like it could work, but probably not practical.
Smart air bricks. Measure something and then goes. I'm not quite sure.
Right.
What
Okay.
they're doing. Why do that? Why just block them up in winter and open them up in summer? Worry about the condensation during the winter leads.
Yeah. Yeah. I guess. Yeah. If there's a product out there that, because it wouldn't be very practical to have to do that, twice a year. Any other questions?
You said you didn't have time, but you've got a little bit of costs. How much?
Yeah, I thought this would come up. I was going to have a slide actually about costs, but I didn't want to. It's so, every project is so different. I didn't want to just put a kind of blanket rate. But to give you an idea, I guess on a Edwardian mid-terrace, so the typical thing we do is, we have a lot of projects that are Victorian or Edwardian mid-terraces, so they're very, architecturally outside something we want to maintain. So that's why we have such an old building stock in this country, is because we have such beautiful houses that we want to keep looking the way they are from the outside. So we'll often do internal insulation on the front and then external insulation on the back where it's less of an issue. So on a typical mid-terrace Edwardian, you might be looking at something like £6,000 to insulate internally with wood fibre insulation, and then externally probably about 8 to 9, because you need that scaffolding and it's much more disruptive. So it's not a cheap thing to do, and obviously it's maybe beyond a lot of people's budgets. But it is the best thing to do that we can do to kind of reduce energy use in our old buildings.
Do you recommend people move their windows when they do external wall insulation?
No, I mean, you need to think about the junction of how the window sits within the wall. Ideally, you want to insulate on the outside and then return it on the reveals so that you insulate some of the frame. So your insulation overlaps the frame, so that because your window is part of the insulation in a way. Obviously, the reveals, you know, probably go for much thinner insulation. You know, if you go too thick, then obviously you start covering glazing. But as long as it's thinner than the frame, then yeah, you can do that either inside or outside. Of course, you need to think about if one day you change the windows, then there'll be some breaking out that you would need to do and making good. So that's something to bear in mind. Unless you can find a way of replacing the windows from the inside, then you don't need to mess around with the outside. Does that answer your question?
When I think about it.
Okay. We've got 2 minutes left. So there's time for a quick one.
On average, how long does it take to get back the money you lay down? What's the return?
On the insulation, generally quite a long time.